Okay, so here we're going to be looking at adding and subtracting planar vectors. So by planar we mean they're in the same plane. So here I've got two vectors in the same plane, and here I've got two vectors in the same plane. So we're going to look at how we can add and subtract vectors in the same plane, but also the limits of that method and where we then have to use one of the other methods that we've been talking about. So if these vectors are planar, they're to an extent either acting forwards or backwards along that plane, and that makes it much simpler to add them together. So what I can do, if I wanted to find the resultant force acting on this box here, I need to look at all the different forces acting. I need to add them all together and find the overall force, or find the resultant force as we call it. So what I'm going to do to start with is start by adding the forces in the same plane. So I'm going to start by adding the horizontal forces acting on this object, and it's probably worth just taking a moment to say this object in this case is just a box, and we've drawn a dot in the middle to represent the centre of mass, which is where the forces are acting from this dot, and that is a simplification. It's a model, and this is called a free body force diagram. So we represent all the different forces acting on this whole body as acting from this dot that represents the centre of mass. And then we can use all these various techniques to find the resultant force. So we're going to add up the forces acting in the horizontal plane on this object. So remember that vectors have got magnitude and direction. So this force has got a magnitude of 4 newtons, and this force has got a magnitude of 3 newtons, but they're acting in opposite directions. This one's acting to the right, this one's acting to the left. And what I'm going to do to represent that is I'm going to make every force that's going to the left negative, and every force that's going to the right positive. So what I'm going to do is I'm going to add these two forces together to find the overall force in the horizontal plane. But I have to remember to include this negative and this positive. So if I'm looking at the horizontal forces, I've got my resultant is going to be equal to 4 newtons plus minus 3 newtons. So I've added this force to this force to find the overall force, but this force is acting to the left, so it is negative. So if I do this sum, 4 minus 3, my overall resultant force has a magnitude of 1 newton, but we can tell from the directions that's plus, so we can say to the right. So it's got magnitude and it's got direction, and I've remembered to make one direction positive and the other direction negative on that plane before I add them together. Now we can do exactly the same thing for the vertical forces. So I have got 4 newtons downwards and 3 newtons upwards. So I pick one of those directions to be positive and one to be negative. So I'm going to make upwards positive and downwards negative. So I'll say here vertical forces. So I'm keeping all of my labelling super clear, so that if I make an avoidable error somewhere, I can still get marks for my working. So resultant force is going to be equal to 3 newtons plus minus 4 newtons. Overall, if I do 3 newtons minus 4 newtons, I'm going to get minus 1 newton. So the magnitude of the resultant force in the vertical plane is 1 newton, and the negative tells me that it's going downwards. Okay, so here I found the resultant, the overall force in the vertical plane. I've remembered to put my positive and my negative in. I found the magnitude and I found the direction. Now, what you can do if you want to, we now have both of these two forces represented by one vertical force, and we've got both of these two forces represented by one horizontal force. You could then use the method of finding the resultant of two perpendicular forces because if one is horizontal and one is vertical, they're perpendicular, to find the overall resultant force and take it further. Now, but I can't just add this 1 Newton force to this 1 Newton force, because the horizontal and the vertical are in different planes, so you can't just add the values together because they're acting in different directions. You have to use the other methods that we're talking about in this learning sequence. So if we just look through some other examples just to check that this is making sense. I've got some other situations here. Have a little think about whether you can find the resultant. So I've got my box, it's got a 2 Newton force to the right, 10 newtons to the left. What is the overall resultant force? Here I have got an 8 Newton force to the right and a 4 Newton force to the right. And here I've got a 5 Newton force to the right and a 5 Newton force to the left. So what are the resultant forces? It might be a good idea to pause the video and try and work these out now, and then we're going to go through the answers when you press play. So for all of these, I'm going to go through the answers now. And all of these I'm going to say that to the right is positive and to the left is negative. Let's change that here. So everything to the right is positive, everything to the left is negative. So this becomes a sum of 2 newtons plus minus 10 newtons, which is going to give me minus 8 newtons. So the resultant force is 8 newtons to the left. Give yourself a tick if you got that one right. On this situation here, I have got 8 newtons to the right plus 4 newtons to the right. So here my resultant force is 8 newtons plus 4 newtons. So that's going to give me 12 newtons to the right. So they were both in the positive direction, so we just add them together, it gets bigger. And then here I've got 5 newtons to the right and 5 newtons to the left. So if I include my positives and my negatives, I have got 5 newtons plus minus 5 newtons. 5 newtons minus 5 newtons is 0 newtons. So the overall resultant force is 0 newtons. There's no overall resultant force. So there's a couple of examples there. If there are any questions about that, do come and ask questions in the lesson. We need to be happy with this concept before we can move on to the other vector skills.